Hey, what's up, guy? Welcome back to my channel. Today, we're going to talk about artificial intelligence. Lately, we have a lot of hype about a technology called ChatGPT, and it's an AI technology that will help us understand language and process language. Some of us even use it to generate story, cover letter. It's magic. But what's the technology behind this ChatGPT platform? Is something called transformer. Transformer is a type of neural network architecture. It has revolutionized not only language processing, but image processing and music generation, a bunch of other applications. But today we're going to learn the small building block of what transformer is, and so that we can kind of get an idea the whole technology, and hopefully in the future you can use that knowledge to expand on to other application. Right, let's dive right into it. To help us understand better, I have prepared a Google Lab notebook. For those of us who have never used Google Lab notebook, it's nothing more than a virtual machine front end. In Google, there is a virtual machine that you will be using, but you don't need to type command. You just need to use this notebook to interact with it and write code with it, and it will execute your code. First thing we want to do is change this runtime because we're running artificial intelligence tasks. We want to use a hardware accelerator being the GPU. There are other options, but for now, GPU is enough. And then once we set that up, we should be good to go to accelerate all the AI tasks that we'll be using. The first thing we want to do is install the library package called Sentence Transformer. Every time the virtual machine is finished, it will get recycled. It will erase everything. That's why we need to reinstall any library package that we want. Let's reinstall it, and it shouldn't take too long, and it's done. Now we have it set up, GPU set up. We have library installed. Let's talk about what transformer is. Transformer is nothing more than an architecture in neural network space. As you can see, there are two halves of the transformer architecture. They are all based on neural network, and one half is called encoder. The other half is called decoder. As the name implies, the encoder is there to encode something. Take some input to encode it into an intermediate outcome called encoded data. What is that is trying to encode? It could be a sentence, it could be a picture. Once it's encoded, it would be kind of like a compressed version of the original data that represent the meaning of the data itself. And how does that happen? It happens by us training the network. Through training, it can strengthen or weaken certain connections so that once the data is done passing through the encoder network, it will have a encoded representation of the original incoming data. Now, for the other half, the decoder half, its job is, of course, decode something. It takes the encoded data, decode it back to the a desired form where, as human, we can make use. For example, if we input a sentence, a word or a sentence, let's say a panda, the word panda, into encoder network, it will end up being a encoded piece of data that has the meaning of panda. Now the decoder can take that meaning and decode it out. It could output as the spelling panda, or it could output as a picture of a panda. But whatever we want to train it to output, it will still represent the original meaning of the incoming data, which is panda, right? So with that, we can decide how we want to train the decoder to get our desired outcome. A piece of music, a piece of art, however we want to do it, right? And what is in the middle then? In what we call latent space. Latent space is higher dimensional mathematical representation space. It could be we human can understand only 3 dimension, but this space could be 100 dimension, 300 dimension. You will see how the dimension looks like in later example of this talk. So enough about transformer and what it is in the high level. We will run the next piece of code. In order to transform something, we need a transformer. This is how you instantiate the transformer. And it takes a model. Since in this exercise, we want to build a search engine, we will use this model, this pre-trained model, to kind of understand the text we're feeding it. Here, we have the encoder or embedder, the synonym in this context. We have loaded it. And then let's look at what are we going to transform. Think of these sentences as the database. You have 5 different sentences. We want the engine to understand each sentence. And later on, we'll search among these sentences. Then first of all, you need to encode these sentences into this intermediate form, encoded data form. So this is how you do it, embedder.encode, and then it will return the tensor. The tensor is the encoded data. If you say encoded convert to tensor equals to true, it will return a PyTorch tensor back to you, and we'll hold it in this variable. Now, let's run this. And then let's look at what it looks like. First of all, let's look at how big is the tensor. It is 384 number long, and we have 5 sets of this 384 number. And it makes sense because we fit 5 sentences. Each sentence is represented by 384 numbers. And those are the gibberish that I was talking about, the encoded data gibberish. Let's see how they look like. Right? Well, I think we can all agree nobody can understand this, but guess what? These numbers does represent the sentence number 2, index 1, sentence number 2 here. Okay. Now, once we embedded the database or the corpus that we will be searching in, then we'll form our criteria. What are we searching for? What is our criteria? What is our question to ask? We call it query. I want to search for in the database a sentence or a document that is related to this query. I am going crazy trying to learn advanced space engineering, right? And then we also need to encode it so that we can do a comparison with the database, because if we both are encoded, then we can do a comparison apple to apple. Here, right? So now we have the query embedded or encoded. Let's stop for a moment and talk about how do we do the magic of searching. The searching happens when we put all the data we have encoded, including the query, into a latent space so that we can do a comparison in the distance. What does it mean is we have 5 sentences. We should have 5 dots here. Each dot represents 1 sentence in this 2D plane, and your query is here. To do the search, all we need to do is find the closest neighbor. And that neighbor, since it's close to you, the context, the meaning would likely be close to your query. And you just fetch those. And that's how you can figure out meaning-wise which one is related to your query. It's all mathematical, but it works really well. Now, why dots in a 2D plane? In reality, it should be a representation of 384 dimension, but we cannot wrap around that dimension in our human mind, so we use a 2D plane to roughly explain the concept. And now let's see what the query look like. Makes sense? 384 numbers, but it's just one sentence, so it's just one row of numbers. And then we'll do the search here. As the name implies, it's not talking about word search, keyword search. It's semantic search. That means it search by the meaning or context, and you return two closest neighbors, right? Those two will be most likely most related to your query. Let's see how it does. First sentence, the highest rank one is, for your peace of mind, do not try to understand everything. Now, I just say my sentence is, I'm going crazy trying to learn advanced space engineering. I never mentioned the word everything. Apparently, it's not doing a keyword search. The engine kind of know you're going crazy, frustrated about space engineering. So the most related sentence would be something like, for your peace of mind, do not try to understand everything, right? So makes sense, right? And the next one is talking about achieving success. It's still in the same vicinity. You're trying to learn everything, learn space engineering. Maybe you were trying to be successful in it. And so it gives you this sentence back. But it's ranked not as high as the other one. So as you can see, it's not doing keyword search. It's not that accurate with keyword search. It has a lot of flaw. But this way is more appropriate. It gives you an impression that it understands your language by only comparing the encoded data, how similar they are. Right? That's all there is to it for this new introductory example of transformer. I hope you learned something from this tutorial. Thank you for watching this. Stay tuned for more. Next time, we will be talking more about a robust way of using this to develop a more full-fledged search engine. See you next time. Bye.